Okay, so in this video we're going to go over the power rule, but for integrals this time. Remember, what did it mean to be an antiderivative? Well, in some sense, an antiderivative was just the reverse of the derivative. So in the derivative, let's say you want to find the derivative of x squared, then you'd get 2x. But now if you want to find the derivative of the antiderivative of x squared, what you do is you go backwards, so you get 1/3 x cubed, because if you take the derivative of this, you're going to get x squared back. But now, remember, how are we going to write antiderivatives? We're going to use this notation, the integral, but this time we don't have endpoints for it. This integral is called the indefinite integral. So if you take the indefinite integral of something, remember, you're not only finding an antiderivative, you're finding all possible antiderivatives. So if you find the antiderivative of x squared dx, or I should say, if you want to find the integral of x squared dx, what you get is 1/3 x cubed plus a constant c, and that constant c represents any number. And remember, that number was called the constant of integration. Constant of integration. All right, so that's a recap of integrals, but this time we're just going to go over a rule, a simple formula you can use when you're finding integrals of this form, x to the p. And how's it going to go? Well, the integral of x to the p power, so you're going to go backwards. Look what happens. You're going to get 1 over p plus 1 times x to the power p plus 1. So all you're doing is adding power p plus 1, but instead of that power coming down, it's going to divide the antiderivative, 1 over p plus 1. And then, of course, you have your constant of integration. Okay? Now, notice that this only works when p is not equal to -1. Why is that? Because you see, when you integrate x to the p, you get p plus 1 in the denominator. And the denominator, or whenever you divide by a number, you know you can't divide by 0. P equals -1 is exactly what makes that denominator 0. So this formula is only valid when p is not equal to -1. So what happens when p does equal -1? Well, the formula actually becomes this. It becomes integral of x to the -1 is equal to ln of x. Okay, so those are the two formulas that we're going to have in our pocket and be using throughout the rest of this section, throughout the rest of the next few videos. And let's practice this with a couple of examples. So I'll put the formula up here in the top right corner. And let's go ahead and do this example. X cubed dx. How's this going to work? Well, that power p is 3. So we're going to get 1 over 3 plus 1, which is 4, x to the power 4, plus the constant of integration, because an indefinite integral gives you all the possible antiderivatives, not just one of them. Okay, let's integrate the number 1. This is also a function. What's the power? This time the power is 0, because anything to the 0 power is just 1. So what do you get? You get 1 over 0 plus 1, which is 1, and then x to the power 1, plus a constant, and of course that's just equal to x plus c. All right, so that's for the second example. This was for the first example. For the third example, you have the power x, the function x. So what's the power? The power is 1. So when you integrate it, you get 1 over the power plus 1, 1 plus 1, and then x to the 1 plus 1. And then, of course, the constant of integration. And so you get 1/2 x squared plus c. And finally, let's look at the integral of square root of z. Now this time it's not explicitly clear what the power is, but of course if you remember that square roots are just fractional powers, now you can see that p is equal to 1/2. So you integrate that, you get 1 over 1/2 plus 1, z to the power 1/2 plus 1, plus a constant of integration. 1/2 plus 1 is equal to 3/2. So right here, that's equal to 3/2. But when you take 1 divided by a fraction, that's the same thing as taking its reciprocal. So what you get at the end of the day actually is 2/3 z to the 3/2 plus c. All right? So that's the integral of square root of z. And notice it doesn't matter what letter you're integrating. That thing is actually just called a dummy variable. So throughout the videos, you'll see that that variable will change because it doesn't really matter what that variable is. Okay, so let's do ones that are a little bit harder. So let's say that you have the square root of z cubed. So you have to move things around a little bit. The square root is a 1/2 power, but you already have the power 3 inside. So what are you going to do? You're going to rewrite it as z to the 3/2 power dz. And so now the power is 3/2, so you'll get 1 over 3/2 plus 1, z to the 3/2 plus 1, plus the constant of integration. That's going to be equal to, well, let's look at this fraction in the denominator. 3/2 plus 1 is equal to 5/2. When you take 1 over 5/2, that's the same thing as taking the reciprocal of 5/2, which is 2/5. So you have 2/5 z, to the 5/2 plus the constant of integration. Done. Okay, let's go to the integral of 6 over x. Well, this is going to be the integral of 6 times 1 over x. But remember, now if you rewrite this as a power, how are you going to do that? Let me put this up here, actually, so we'll have a little bit more room. Right here. Okay? So if you rewrite that to get the power, you get 6x to the minus 1 dx. So now the power is minus 1. That means you can't use this first formula. That's not what we do for problem 6. Okay? So instead, we have to use the second one. And so we'll get 6 times ln of x plus the constant of integration. And that's the answer there. Finally, let's do integral of 1 over 2 square root y. So now y is the variable. And, well, you're going to do the same thing, except now square root is a 1/2 power. So if we rewrite that, we'll get 1 over 2 y to the 1/2 dy. And here's where some people get confused. All right, that 2 is a constant. It stays there. Nothing happens with it. Now that y, you want to find out what the power is on that y, but the y has to be in the numerator. So if you want to move it to the numerator, it's going to become y to the minus 1/2. And you see how that 1/2, it just stays there. The 2 stays in the denominator. All right, remember, why do we want to do that? Because the power rule says, or only tells us what to do when your function looks exactly like x to the p. Okay, so what is the integral going to be? It's going to be 1/2. And now what's the integral of y to the minus 1/2? It's going to be times 1 over the power minus 1/2 plus 1 times y to the minus 1/2 plus 1 and plus your constant of integration. So let's simplify that. We're going to get 1/2 times, well, what's minus 1/2 plus 1? That's just a half right here in the denominator. So when you simplify that, you'll get 1 divided by 1/2, but that's just the number 2, right? Because you take the reciprocal of 1/2, that's 2. And then you have y to the 1/2 plus the constant of integration. And you can simplify, 2 cancels out, and you just get square root of y plus c. And there's your answer, because 1/2 power is just square root of y. All right, so that's just a couple of examples to get a feel for the power rule. You're going to be doing a lot of these in the web work or in the homework, but this will definitely take a lot of practice. We're going to do some more advanced ones in the next video, so stay tuned.